Unit 5, Module 2, Session 2. It is called Parallels, Perpendiculars, and Angles. We are going to review parallel and perpendicular lines by examining figures that are examples and non-examples. We will define parallel and perpendicular lines again and in our own words, and next we will complete a work sample that asks you to draw parallel and perpendicular lines and measure acute and obtuse angles. So you'll see this picture on the side here that has a printable protractor. You are probably, I emailed this to you and your parents. You may want to print this for yourself so that you can use this for the activity as well, okay? All right, so let's go over parallel lines for a minute. Remember that parallel lines always are the same distance apart, and we can see parallel lines on the ceiling in our school. We can see parallel lines on windows. We can see parallel lines on ladders. We can see them in many places, so they're always the same distance apart, and they are lines that are right next to each other, but they will never meet and they will never intersect. We also have what are called perpendicular lines, and those lines are going to intersect at right angles. So when you see a crisscross on a window, they meet at a perpendicular line. When you are riding your bike or you're driving in a car and you come to an intersection, oftentimes the intersection is at a right angle, and those are perpendicular lines. All right. And then we also have angles. An angle is formed by two rays or line segments that share an endpoint. They're often measured in terms of the amount of rotation expressed as some number of degrees needed to superimpose some of the rays or line segments to the other. So we have different kinds of angles. If you remember, we have acute angles, which are more than 0 but less than 90. We have right angles, which are exactly 90 degrees. And we have obtuse angles, which are more than 90 but less than 180. All right? So you can see that right here we have a right angle. Right here we have an acute angle. And right here we have an obtuse angle. Okay, and you'll see angles in shapes, and then you'll just see angles in different places as well. All right, so today we're going to continue to work with lines and angles. So take a look at the pictures in the boxes below. Typo, sorry about that. Think about the lines and what the sets of lines in the left-hand box have in common. So when you think about the lines in this box right here and what they have in common, okay? And then think about the lines and the set of lines in the right box and what they have in common. Okay, so just think about those. And while you're thinking about that, I would like you to open up your student book to page 181, and you will see these same boxes that we were just looking at a moment ago. Okay? So it says to study the diagrams that I just showed you. So we have, remember, these, and we also have these. These are going to help us, okay? So for number 1, it says study the above and use it to help you to answer the questions below. A says circle all of the examples of parallel lines in the box. All right, so remember that parallel lines are never going to intersect. They are always the same distance apart no matter where they are. I see parallel lines right here. I see parallel lines right here. If these ones right here were to keep going, they would eventually cross, so those are not parallel, right? Okay, so not those. Not those, not those. These right here are parallel. They will never intersect, okay? The other ones are not parallel, so I'm going to leave them alone. B, it says, how do you know that the figures you circled are examples of parallel lines? Well, I know because they will never cross. C, draw 2 examples of parallel lines. All right. You may do the same thing in your workbook, okay? All right, there's one pair of parallel lines. We'll draw another one going like this. And then it says draw 2 examples of lines that are not parallel. Okay. And then write a definition for the term parallel lines. I haven't used this one. Let's see here. Lines that are always the same distance apart. You can write this definition, or you can write your own definition in your book and upload that to Seesaw when you are done. All right, and then we're going to go on to the next page, okay? Okay, student book, page 182. Now we're going to be thinking about lines again, and you'll see that we have perpendicular lines on one side, and then we have lines that are not perpendicular on the other side. Okay, so I want you to study the diagram just like you did before. And the first thing says to circle all examples of perpendicular lines in the box. All right, well, these ones are perpendicular because I know that when this line crosses over this one, it's going to form a right angle. These are also perpendicular, and this one's a little bit more difficult to see because the angles they're kind of turned, so they're kind of on an angle. You almost have to turn your paper to help see that one. And we have one more set of perpendicular lines. They are right here. They form right angles when they cross. So question B says, how do you know that the figures you circled are examples of perpendicular lines? Because they meet or cross at right angles. B or C, sorry. Draw two examples of perpendicular lines. Okay. There's one. And here's one. Okay, as long as they form those right angles, they are perpendicular. And then it says draw two examples of lines that are not perpendicular. These ones intersect, but they do not form right angles. These ones do not intersect, so therefore they are parallel. And then finally, write a definition for the term perpendicular lines. I'm going to say that perpendicular lines are lines that make right angles when they cross each other. Okay, all right, so there's that page. We'll come to the next page in just a little bit here. All right, so I want you to think about the picture below. This picture right here that we see. Lines A and B, if you'll notice. Lines A and B, they seem to be parallel to each other, and I know that because they are not going to intersect. When you look at line C, however, it is actually perpendicular to lines A and B, right? And I bet a square pattern block would help us to check if that was right. So we happen to have this square pattern block here, okay? All right, so we're gonna go to the next slide here and look at that. Since we can clearly see that the square pattern block fits perfectly in the corner, I know that those are right angles, and this helps me know that all of the angles are right angles. Okay, so there's that. Moving on. Take a look at this picture below. Now when I see lines D and E, so I'm gonna highlight D and E for a moment. Here's line D, and here's line E. They appear to be parallel to each other. And line F, I'm gonna highlight line F. Line F goes through both of them, but it's not perpendicular. Line F goes diagonally through them, but not at a right angle. You'll also notice that there are 8 angles. They are actually numbered. And if you look very carefully at those 8 angles, okay, it looks like 4 of them are acute angles. Angle 1, angle 5, angle 4, and angle 8, they are acute. But then when I look at angle 2, angle 6, angle 3 and angle 7, they are obtuse. So we have 4 acute and 4 obtuse angles. So it looks like some of the angles are the same. So to me, if you look very carefully, angle 2 and angle 6 appear to be the same. Angle 1 and angle 5 appear to be the same. Angle 3 and angle 7 appear to be the same. And let's see here, angle 4 and angle 8 appear to be the same. Looks that way to me, which would tell me that they're probably the same degrees, okay? All right, then I want you to think about this picture below. You're going to see this on a work sample, and you will need to complete it. This is very similar to a problem that we have already talked about. So I want you to be sure to look at the lines very carefully and think about what kind of lines you see, okay? Think about similarities and think about differences with the angles that are there, all right? So you will see this on a work sample that you're going to complete in Seesaw, okay? And this says to use a protractor to help you determine the measure in degrees of all 8 angles. Record them in the boxes below. So there are 8 angles, just like in the previous picture that we saw. You're gonna record the measurement of the 8 angles, okay? Think about this picture a little bit to help you with that, okay? All right, so in Seesaw, you will see an activity that looks like this. It's called Lines and Angles Work Sample. This is something that you should work on independently, and you will probably want to use that printable protractor that I emailed to you, okay? Let me know if you have any questions. However, so I want you to put it in Seesaw, but if for some reason the activity is not working for you, then you can take a screenshot of this piece of paper right here and you can complete it like this, all right? So that's part of the activity. Let's move on to this next page in our student book called Thinking About Triangles, okay? Use the following information to help solve the problems below. It says you can group triangles by the size of their angles. So you can see that we have acute triangles. And if you notice, each of the angles on an acute triangle, each of the angles are acute. You also have what are called right triangles. When you look at right triangles always have one right angle. They're always going to have one right angle, okay? And then you have what are called obtuse angles. Obtuse angles are always going to have one obtuse angle, okay? All right, you can also group triangles by the lengths of their sides. We have equilateral triangles, and you'll notice that in an equilateral triangle, all of the sides are the same length. So those 3 sides that I just highlighted are the same length. The 3 sides of this triangle are all the same length. And the 3 sides of this triangle are all the same length, okay? So all 3 sides are the same length. You have what are called isosceles triangles. Isosceles triangles have 2 sides that are the same length and 1 that is different. So when you look at this triangle right here, you'll see that this side and this side are the same length, but you have 1 triangle right here that has a different length, okay? When you look at this triangle right here, you have this side and this side are the same length, and this one is a little bit longer than those 2. And when you look at this triangle right here, this side and this side are the same length, and this one right here is a little bit shorter than the other 2, okay? That's an isosceles triangle. And one way that you can remember isosceles triangle is that it's got 2 S's that are at the beginning of it. There's another S though. It also has 2 E's, isosceles, okay? So that's how I remember that. And then you have scalene triangles. In a scalene triangle, no sides are the same length. That means that all 3 sides are different lengths. So that means that this side right here is a different length from this side, which is also a different length from that side. And on this other triangle, this side is a different length from this side, which is also a different length from that side. So that is called a scalene triangle. The way that I remember these ones is that they kind of lean a little bit. Sometimes you see a scalene triangle leaning because all of the sides are different lengths. That's one way that you can kind of remember how that one goes, okay? So we have, again, equilateral triangles, we have isosceles triangles, and we have scalene triangles. We also have, you can group them that way by their angles, or by their sides, sorry, but you can also group them by their angles, meaning acute, right, and obtuse. Okay, so for number 1, it says fill in the bubble to show what kind of triangle each one is. So for number 1, if you look at it very carefully, it's either acute, right, or obtuse. If you look very carefully at this triangle right here, you can see that it has that one obtuse angle. As long as it has one obtuse angle, my friends, it is an obtuse triangle. Okay, let's look at B. All right, looking at that angle, it says it's either an acute, a right, or an obtuse triangle. Well, it gives us a clue when you look in the corner right here that this angle right here is a right angle, okay? So B is right. As long as it has one right angle, it is a right triangle. For C, this one says acute, right, or obtuse. When you look very carefully at all of these angles, this angle, and this angle, they are all acute. Therefore, this is an acute triangle, okay? Looking at D, it's either equilateral, isosceles, or scalene. When I look at it very carefully, I see that this guy right here is short, but the other two sides are different. The other two sides are the same length. And if I look back up at this chart over here, when there are two sides that are the same length, that is called an isosceles triangle, okay? When you look at E, it's either equilateral, isosceles, or scalene. I'm going to highlight the sides here. We've got this side here, okay? Then we have this side, and then we have this side. All of the sides of this triangle are all different lengths, which means that this is a scalene triangle. And finally, we have F. When I look at F, it's either equilateral, isosceles, or scalene. When I look at it very carefully, I can see that this side, and this side are all the same length, which means that this is an equilateral triangle. Okay, you may fill this in your student book on page 183, and then you, on your own, are going to complete Home Connection book page 95, Home Connection book page 96, and Home Connection book page 97. If you have any questions, please feel free to let me know. It shouldn't take you too long. Even though it's 3 pages, there's actually not a lot on these pages, okay? So I want you to go ahead and fill those out. And actually, if you look at page 95, that's simply an information page. So you're basically looking at that to help you with pages 96 and 97. All right, that is your work for today, boys and girls, and I will see you tomorrow. Have a great rest of your day.